ultimately, when you think of data center of the future, everybody's expectation is that more, right? You're going to have more bandwidth. You're going to have more types of compute. That it's Moore's law is dead, so you need specific accelerators of some kind, and you need some cheap, efficient way of constantly integrating new kinds of accelerators. AI AI workloads change constantly, and so if you want to do that, if you want to have different kinds of accelerators, chiplets today are sort of the only known fastest best way to build heterogeneous systems together where you have multiple different types of compute all bundled into one package. And it's not just the functionality, the actual I/O bandwidth has to increase dramatically as well. So either you have an I/O bandwidth into memory and I/O bandwidth into in terms of the raw network that everybody else thinks of Ethernet bandwidth. In both cases, we have companies associated with the ODSA trying to solve those problems. One company which is trying to sort of dramatically widen the amount of types of memory you can use in high performance systems by abstracting them away from the main chip so that you have to tape out a new chip every time you want to use a new type of memory. And we've just seen within our experience center, there's a demo from a company that's building I/O called Candu that's building I/O with chiplets so you can scale the amount of network bandwidth you want leaving your device. It can be scaled in terms of Ethernet chiplets, can be scaled in terms of PCI chiplets. So whether it's the type of compute that you see in the data center, whether it's the type of I/O that you see, memory or network I/O, chiplets are going to be, and of course, if you want to go optical, co-packaged optics is pretty much the best way to integrate optical into a system. So you glue all this together, where any part of the future data center, especially an AI intensive workload, the expectation is that some kind of a chiplet-based system is going to be essential to meeting that requirement. And at the OCP, there's a fundamental belief that open interfaces are the best way to integrate systems that create systems that integrate chiplets, devices from multiple vendors into one composable whole that's usable.